6.2 Inverse functions and relations. So we're going to talk about what inverse relation is. Very, very simple. Inverse relation means you just switch the x and y values. That's it. Anytime you hear inverse, you just want to switch x and y. That's all inverse relation does. Look right here. There's x and y, x, y, x, y. You want the inverse relation? Switch it. So 5, 1, 6, 2, 7, 3. That's all. You literally just switch them. Don't do anything else. Now, is that a function? You gotta check to see if all the x's are different. In this case, yeah, it's a function. Sometimes it won't be. But that's how you do it inverse relation. Just switch all the x and y's. That's it. That's what inverse means. Literally switch x and y. Alright, so we're gonna find the inverse of each one, then I'm gonna ask you if it's a function or not. So again, inverse of this will just be, by the way, inverse notation, let's say this is f of x. The inverse notation is this. The negative one is the power. That means inverse. So it says f of x, let's do inverse notation. So inverse would be 10, negative 9, curly brackets, negative 3, 1, and negative 5 and 8. And this one is a function, all the x's are different, so it's an inverse function. So that's our inverse function. By the way, while we're here, let me show what the graph does. What does it do to the graph of it? So let me go pick my shape out. Let's do it over here. Bring it a little bigger. There we go. Okay, so we have that. Let me paint these in blue to start off. So I'm going to do the original function in blue, and I'm going to go in order like that. So negative 9, 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to be perfect, but I'm going to try my best. It's like around there, right? And then 1, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so 1 and negative 3. And then 8 and negative 10. So 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, around there. And negative 5. Around there. Now when you connect, you're supposed to connect them in that order. So that order. So it's something like this. And like that. Okay, so that's the original function. Now let's graph the inverse function. Do that in green. I'm going to go in the same order. I have to go this way, right? So if that was first, that's first. So 10, negative 9. 10-ish, negative 9-ish. Negative 3, 1. So negative 3 and then 1. Then negative 5 and 8. If I connect this one, again, same order with the first one I drew. Oh, that's not great. And that one right there. Now, if you could kind of see what happens, what it did is it flipped it across this line here. Not my best graph, but what it did is flip it across there. So when you do an inverse graph, you flip it across this y equals x line because you switched the y and the x. So it flipped it across there. Anyway, so that's what the inverse graph does. Next one. So again, if I want the inverse function, the inverse relation, it's not a function yet. Just switch it, so it's 9 and negative 2. It's negative 1 and 4. 9 and negative 7. And 7 and 0. And if you look at this one's actually not a function. It's inverse, it's not a function. It's an inverse relation. So I get that. Again, if I would have done the same thing, if I would have graphed this one, I would do the exact same thing. I'm just going to even cheap the last one. Negative 2, 9. 4, negative 1. Negative 7 and 9. 7, 0. So this one, let me do the original one in black. It's like this. They didn't have proper notation, so that's why I'm just scoring from left to right like you're supposed to. Then we graph the inverse. So here's the thing. So 9, negative 2. Let's look around there. Negative 1, 4. 9, negative 7. And 7, 0. Oh, I didn't flip this one. 0 and 7. So this one looks like this. Something like that. Again, not the perfect graph, but the idea is you're supposed to flip across that line. You kind of see it. Again, not perfect. These should have crossed right there. But that's the idea. Flip it across the line. So the general idea is if I give you a graph, I'm like, hey, here's my function. I say, I want you to graph the inverse. What you do is, you could get this point here, spin it across that line, and then your graph becomes spin across there. I'm not the best at this. Kind of like this. So that's one way you could do it. Or you do the way I do it, which is I pick points, -3 and 2, and I go, okay, let's switch that point to 2 and -3, and I graph that. So that's why I do it. I just kind of pick points and then I flip them. But either way works. But that's how you graph an inverse function, right? Inverse function flips across the y equals x line. So find and graph inverse, just like I talked about. So just like I talked about right there. That's what this is about in less words. Anyway, so for these, we're going to talk about how to find the inverse of an equation. So we talked about how to find an inverse if I give you points. If I give you points, you'll switch them. I talked about how if you do it with the graph. If you give me the graph, well, literally just flip the points and graph them. Or if you're good at art, and you could draw a line across right here and then flip it across there, then that's another way to find an inverse. So either switch the points, or flip it across the y equals x line. So we did it by graphing, and we did it by points. The last thing I got to do is how do you do if I give you a function? So if I give you a function f of x, how do I find the inverse of it, which is f of x to the -1? Well, just a couple steps. First, change f of x to y. Remember, f of x and y are the same thing. So we're going to change the y just for you, we work with it better. 2, this is the inverse step, is an important part. Switch x and y. Right, that's the inverse step, that's the important part. And finally, solve for y. I guess, and then last we go change y for f inverse x. Really, there's 2 steps, right? Like f of x to y, whatever. It's switch x and y and then solve for y. These are the important steps, right? Switch x and y and then solve for y. So first I'll make this a y. And then I'm literally going to switch the x and y because I want to do the inverse. Everything else stays exactly the same. Now I do solve for y. So divide by -3. Y equals x over -3. I should change, sorry. F at -1 power equals x over -3. Like that. They want you to graph functions inverse. I want you to do a couple of times and all the time because they haven't, like that one is, we're not graph that. Start there, go down 3/1. We graph it looks like this-ish. And then if I want to graph the inverse, that, we know how to graph that. Start at 0. Slope is down 1 and over 3. The graph looks like that. It's a little hard to tell with this picture here. And also my bad drawing. But it does flip across there. Again, we're going to skip that most of the time on this case because a lot of times they don't even give you graphs you haven't learned yet. So I'm just going to skip that for now. Next one. What am I doing on this one though? Because I like this one better. Same idea, right? Let's find the inverse. So we're going to switch x and y. Make that a y. Switch x and y. So it's going to be x and y. Solve for y, so add 6. X plus 6 equals 4y. Divide by 4. And we get y equals x over 4 plus 6 over 4. Also known as f inverse of x equals x over 4 plus 6 over 4. And that's the inverse. Again, if you wanted to graph the graph in its inverse, we know how to graph that. Down 6, up 4/1, something to this effect. And then if you wanted to graph the other one, plus 3/2, so like up here, up 1/4. So it's something like this. So they actually do cross right here. Ish. And again, if we draw the inverse line, it's y equals x, which is right down the middle. Something like that. So I flip across that line. Anyway, next one. This one where some people mess up. So it's the exact same idea. Y equals x squared minus 3. When I say switch it, I mean just the letters. Nothing else moves, just the letters. So you just transpose the letters, x and y there. Just transpose them. Everything else stays. So it's still an equal sign. There's still a square on that part. It's supposed to be a different color. Still an equal sign. Still an x on that part. Square on that part. So we get that. So you literally just switch the letters. That's the inverse step. Solve for y. X plus 3 equals y squared. Square root it. And we get y equals plus and minus x plus 3. This is one of the things we haven't learned how to graph that yet. That's something like, I was a little like, we don't have to graph all of them. So that's something we haven't learned how to graph yet. That's actually the next lesson. Anyway, last one of these to practice. Right, so let's find the inverse of this. So I'll make that a y. X plus 1 squared plus 3. We're going to switch x and y. So that becomes x and that becomes y. Now we have to get the y by itself. So first thing I'm going to do is subtract the 3. So x minus 3 equals y plus 1 squared. Then we're going to square root it. Plus and minus x minus 3 equals y plus 1. Then subtract 1. So negative 1 plus or minus x minus 3 equals y. Or we could change that to f negative 1. F inverse. So that's how you find the inverse of a function, right? Just switch x and y. If I give you an equation, if I give you points to switch x and y, if I give you a graph, you can switch the points and then graph them. Or you can flip it across that y equals x line. And if I give you an equation, just switch x and y and solve for y. These application problems are actually kind of dumb. So we're going to go on to horizontal line test and tell it's a function. Okay, so these are horizontal line tests to determine whether each inverse is also a function. So all they want you to do here is graph this thing. In this case, it looks like this. It's actually probably going to be more like this. You could graph on a calculator, but it's going to be more like that. An easy way to tell if does this have an inverse function or not is do a horizontal line test. You actually don't have to graph the inverse. You just do a horizontal line test. Then you can tell if it has an inverse function or not. Like this one would not. So a one-to-one function is a function that has an inverse. So if it passes this test, then it has an inverse function. This one does not. No inverse function. That's all that's about. If you look at some of the ones we did up there. Let's go back to the very start. Right, that blue line would pass the horizontal line test, and its inverse is a function. Look at this one. The black line would not pass the horizontal line test. Right here it fails. If I draw a horizontal line, it fails. So, and if you notice, the orange line is not a function. Same thing here. Right? The black line right there would not pass the horizontal line test, and its inverse is not a function. So an easy way to tell if something has a function or not, do a horizontal line test. Like this one, its inverse will have a function. So it does have an inverse function. This one would not. So that's all it's about. And the last thing. So here's another thing. Here's another way to tell if two things are inverses of each other. There's a special property that has this. If we do that f of g stuff, and they cancel out, and you just get the x back, then they're in an inverse. The function and its inverse cancel each other out. So if you do f of g or g of f, it could be either one. If it works one way, it should work the other way. If that happens, then they're inverses of each other. So let's try here. Let's do f of g of x. So I'm going to plug g into f. F is this. Let's plug g in there. Look what happened. 7 minus 7 just gets me x. Those two things are inverses. You're supposed to check the other way, but honestly, same thing works. Plug that in there, 7 cancel out, you get x. So it's an easy way to check the two things are inverses of each other. You just plug one into the other. If they cancel each other out, then they're inverses. If they don't, they're not. Like the next one. Right? So let's do f of g of x. So I'm plug g into f. F is this. Plug g in. So I'm going to get 1/3 square root of x. Now that 3 does not cancel any of that out. 2 does not count. This isn't, like, can't do anything here. So this is not inverse. It's a function, it's not an inverse function. Then, or I should say f and g are not inverses. It's more accurate. So f and g are not inverses of each other. Let's try one more. So again, it works either way. We've been doing lots of f of g. Let's do g of f on this one. Now again, if they're inverses, we're going to count each other out. So we're going to plug f into g. So I like to write out what is g. G is this thing. Then we're going to plug in f. F is this thing. First thing that happens, we have to distribute this 3. And I'm going to get 3, yeah, those cancel out. X squared plus 3 minus 3. And then these cancel out, and I get square root of x squared. And then those cancel out, and you just get x. So yeah, these are inverses. And again, if you want, you could do it the other way also. You could plug g into f. I could do it the other way. So I'm going to plug that into there. So f is this. And let's plug in the g function, which was this thing. First thing that happens, the square and the square root cancel out. You get 1/3 3x minus 3 plus 1. Then we distribute the 1/3, and I get x minus 1 plus 1. And then the 1's cancel, you just get x. So, a nice easy way to tell if using an inverse of each other, just plug them into each other. Do f of g of x. If they cancel out, inverses. And that's the lesson.